Making games with JavaScript is one of my favorite ways to practice coding. Today, we will build a 2D game and we will animate everything to bring it to life. I want to show you how to make keyboard controls feel quick and responsive. We will apply animated sprite sheets and parallax backgrounds. We will learn how to give our game different skins. We will explore a new technique to make particle effects, and we will challenge our players by giving different enemy types different behaviors. On my community page, I asked you to choose between 3 superpowers, and you chose the Fireball Tackle. So let me show you how to turn into a flaming ball of plasma and vaporize enemies to earn points. Come join me and learn how to create your own 2D adventures with HTML, CSS and plain vanilla JavaScript. No frameworks and no libraries. Click the like if you want more games. To keep the code organized and easy to navigate in, I will split JavaScript into multiple files, so-called modules, and I will export and import them around the codebase as needed. To enable this functionality, we have to run our code in some kind of dev environment. They need to be run through some kind of server. You might already have a preferred way to run a local server. You can go ahead and do that. For the rest of us, the easiest way to create a simple local server is to use VS Code editor, which has a built-in one. When you open your VS Code, check if you have this notification area down here that says Go Live. If you can't see it, you can just come here to Extensions and search for Live Server. It's this one. Mine is already installed. You can just click Install here. When you install it, close your VS Code and reopen it, and you will see Go Live down here. One last thing to do, we have to point VS Code to the correct folder with the files we want to run through this live server. We do it by going to File, Open Folder, and in there you navigate to the folder you will work with today on your local computer and click Open. Now, when I create new files, they will be automatically created in that folder. So I create index.html, style CSS, and main.js. In index.html, I create a basic blank web page markup. In VS Code, you can just press exclamation mark and tab key and it will create it for you. Let's give it some title and a link style CSS file like this. I create a canvas element with an ID of canvas1. Down here, I link my JavaScript using a script tag. I give it type attribute and set it to module to specify that this file will be a JavaScript module. It will be my top level module and we will be importing other JavaScript modules inside. I click this Go Live button and the Live Server plugin will automatically open my default browser and it will run our project in it. It will also automatically reload the browser window whenever we save any of the project files. You don't have to use VS Code and Live Server plugin. If you know how to create your own local server in a different way, feel free to do that. So now I can see my live server is running on port 5501. It will reload browser window whenever I save any project file. I usually use Ctrl+S keyboard shortcut to save. Sometimes you have to manually reload the browser page for the first time and then it will start doing it automatically. In style CSS, I reset margin and padding to 0 on all elements and I set box size into border box. This is so-called global reset and we do it to make sure our page looks the same across different browsers. Canvas 1 will have border 5 pixels solid black and I center it in the middle of the page, so the usual 4 lines of CSS, position absolute, top 50%, left 50%, transform translate -50%, -50%. I will provide you with game art assets you can use to code along with me, and at the end in the experiment sections I will show you how to apply different skins to your game so that you can make it unique based on your own creative preferences. Check out this website for more beautiful art assets that are already compatible with today's project. Today we will be using images for player, backgrounds, enemies and other things. The easiest way to make sure our code runs only after all art assets are loaded is by placing the images inside index.html, which we will do in a minute, and we will put all JavaScript inside a callback function on event listener for window load event. That way, JavaScript waits for all dependent resources such as style sheets and images to be fully loaded and available before it runs. When the page is fully loaded, we will point JavaScript towards our canvas element using its ID. I create an instance of built-in 2D drawing API using getContext method and I save it as CTX, shortcut for context. Canvas width will be, for example, 500 pixels and height 500 pixels as well. You can make your project wider, but keep the height at 500 pixels for now because I optimized the background images for that size. We can make canvas scale up and down to make sure it's always fully visible. If I set width to 1500 pixels, we can only see the middle. It's cut off on left and right. I can give it max width 100% and it will make it scale down until it's fully visible, whenever the width of the page is less than the width of the canvas element. I can also give it max height 100% in case that the restricting factor is page height. Now we can always see the entire canvas regardless of its width and height. I set it back to 500 for now. The main brain of our project will be this game class. All logic in our project will somehow go through it. It will expect width and height as arguments, and inside we convert these to class properties like this. It will have update method that will run for every animation frame and trigger all calculations that need to happen, and draw method will draw our images, score, and so on. Right now we don't have anything to update or draw yet. I create a new JavaScript file called player.js. If you are a beginner, it will be easier for you if you follow my code exactly and use the sprites and images I provide you. And only once you have a working project, then you can modify it and add your own art assets and game features if that's what you want to do. Inside player.js, I create a class called player. Its job will be to draw and update our superdog character. Constructor will take the entire game object as an argument. Through it, we will have access to some things we will need, such as width and height of the game area and so on. JavaScript objects are so-called reference data types, which means when I pass the entire game object to other classes like this, I'm not creating a copy of the game object, I'm just pointing to it. So now it's time to bring player image to the project. It was provided by this talented artist and you can download it for free in the video description and use it for learning purposes to follow along with this class. Check out their website for more game art assets if you want to make your projects unique. So we have some images and sometimes it can take a while, maybe even a couple of seconds for the images and audio files to load. In JavaScript, if you try to use an image that hasn't yet been fully loaded, you will get an error. We need to make sure our images are loaded and available before we draw them. One way to do that, and the simplest way to do that, is to actually include those images on our web page. I simply create an image element, and as a source, I point it towards the image file. I have a folder called assets in the same place where my index.html file is, and in there, the image I want is called player.png. I give it ID player like this. I will draw that image on canvas with JavaScript, so I don't really want to display it on the web page like this. In style CSS, I target it using its ID and I set its display to none. It's a good practice to make your images the exact size you will use in your projects. We can scale it down with JavaScript, but for maximum performance it's better to size your images in Photoshop or some other graphics editor. I already did that with the images I gave you today and I sized each frame to the same size we will display in game. The width of each single frame in the sprite sheet will be 100 pixels and height will be 91.3 pixels. If you are using your own sprite sheets, you can get the width of a single frame by taking the width of the entire sprite sheet and dividing it by the number of horizontal frames. And height is the height of the entire sprite sheet divided by the number of vertical frames, the number of rows. Player will also need to be positioned somewhere on canvas, so it will need X and Y position. It will have update method that will move it around based on user input and it will cycle through the sprite frames, and the draw method will take those values and it will draw currently active frame at the current coordinates. It will need context as an argument to specify which canvas element we want to draw on. Let's start by calling fill rectangle first, and we draw it at coordinates this.x, this.y, and we also specify its width and height. If I want to use this JavaScript class in a different module, in a different file, I need to export it. I can just say export like this. Each file can have unlimited amount of exports. Or I can say export default. Each file, each module can have only one default export. In main.js, I import player class by going up top and saying import player in brackets like this from ./player.js in quotes. Class constructor on JavaScript class is a special type of method. It gets automatically executed when we call this class using the new keyword. It will create one new instance of this class, and as a side effect, all the code inside the constructor will run. We can take advantage of that by putting in any code we want to run at that point. When I create an instance of game class, I also want to automatically create an instance of player class. Since I'm importing player class on line 1, I can instantiate it here. This.player property on game class will be new player like this. Inside player.js on line 2, I can see that player class expects game as an argument. So here, since we are inside that game class, I will pass it this. Inside game class, this keyword means this game object. Now that we have access to the player object from within game class, here inside draw method I can take this.player from line 13 and I call its draw method. We declare that draw method here on line 12 inside player.js, and I can see it expects context as an argument. My main public method will be this draw on game class. It will get context passed from the outside in a minute, and we will just pass that reference along to player draw like this. Our game class is complete. Let's create an instance of it. I need to pass it width and height, so I pass it canvas width from line 6 and canvas height from line 7. So now we created an instance of game class which triggered class constructor, and that automatically triggers class constructor on imported player class and also creates our player. Make sure you save changes to both player.js and main.js file every time you make any change. If you have any unsaved changes in player.js at this point, you will not get the same result as me. I console log a game and I can see it has height, width, and it contains player object as we defined in the constructor. Perfect. We will also need animation loop because I want the game to update and draw over and over 60 times per second. I create a custom function I call, for example, animate. Inside I call game.draw from line 18, and as context I pass it ctx from line 5. Then I call request animation frame and I pass it animate to create animation loop. When I call it, we are drawing this black rectangle representing player object. Nice. This code inside draw method on player class will determine what the player looks like. I can make it red, for example. I can move it around by changing its coordinates. If I want to align the player on the bottom of the game area, player object needs to be aware of game height. I have width and height of the game area here as properties on game object, and I'm passing a reference to the entire game object to the player here. Inside player.js, I convert that reference to a class property called this.game, and I can extract width and height of the game from that. So to position the player on the bottom of game area, I set its vertical y coordinate to this.game.height minus this.height, height of the player. I don't really want the player to look as a red rectangle. We have a special sprite sheet with our superdog to use here. We are about to learn how to use built-in drawImage method to animate a game character from a sprite sheet. If you want to go deeper on sprite animation, the very first episode in the series linked below will explain it in a beginner-friendly way. This is an advanced video. If you feel it's too challenging for you at some point, don't worry, it will make more sense if you keep going, and you can always watch a special episode describing each technique on a simpler project. So drawImage is a special HTML canvas method we can use to draw and even to animate an image. It's simple. I have my player sprite sheet here in index.html and I gave it an ID of player. I create a property on player class called this.image and I point it towards that image element using getElementById. Now I can draw that image. drawImage method needs at least 3 arguments: image we want to draw and x and y where to draw it. By the way, I'm not sure if you know, but I don't really have to use getElementById here. I give my image ID of player here, and JavaScript automatically creates references to all elements with IDs into the global namespace, using its ID as a variable name. So I can simply just use that ID as a variable name here, and it will still work. It's a bit strange, and for some reason nobody uses this feature, but it will work. I will go back to getElementById here, even though it's kind of redundant. drawImage method can also accept optional 4th and 5th argument for width and height, and it will shrink or stretch the image to occupy these dimensions. Now it's just squeezing the entire sprite sheet into the small space. The longest version of drawImage method takes 9 arguments, and that's the version we need. We pass it image we want to draw, source x, source y, source width and source height of the rectangle we want to crop out from the source image, in our case a single frame of the sprite sheet, and destination x, destination y, destination width and destination height will define where on destination canvas we want to draw that cropped out rectangle onto. At first, I just want to crop out the top left frame in my sprite sheet, so I crop from coordinate 0, 0, and the area will have a width of 100 pixels and height of 91.3 pixels. I'm cropping out exactly 1 frame. I don't need the red rectangle anymore. We are redrawing the same image over and over 60 times per second, but it looks static. Let's check if we are actually animating by putting some code inside player update method. For every animation frame, I want to increase player's horizontal x coordinate by 1 pixel. To To actually run the code, I need to go to update method on game class, and I take this.player from line 13 and I call update on it like this. Finally, I call game.update from inside animation loop and we have some motion. Congratulations, you are a JavaScript animation master. Okay, we can do a bit more with this if you want. The dog is leaving a black trail behind. That's old paint, we can just see all the previous frames. If you want to see only the current animation frame, we need to clear canvas each time we update and draw. I call built-in clear rectangle method, and I want to clear the entire canvas from coordinates 0, 0 to canvas width, canvas height. Now we can just see the current animation frame. I don't really want the player to move like this. Let's comment this out. I want the player to move left and right, jump, and to use superpowers based on keyboard inputs. I create a new JavaScript file, a new module. I call it input.js. Its job will be to capture and keep track of user input. Again, I will create a JavaScript class here. I will call it, for example, input_handler. Inside its constructor, I create a property called this.keys, and I set it to an empty array at first. I will be adding keys that are pressed down into this array and removing the keys that are being released. That way we can always check if a specific key is pressed by checking if it's included in this array. As we said before, the code inside a class constructor is executed automatically whenever we create an instance of this class, so I will take advantage of that and I will apply keyDown event listener from here. Event listeners return an auto-generated event object, which contains all kinds of information about the event that just occurred. The property that holds the name of the key that was pressed is called key. So let's console log e.key. I export input handler up here. Inside main.js, I import my new input handler class, same as I did with player. I will create an instance of input handler class inside game class constructor. I will call this property this.input. This way, input handler class gets automatically instantiated when I create an instance of game class. It will create this.keys array from line 3 and it will also automatically apply this keyDown event listener. Now, when I press keys on my keyboard, I can see their values. I don't want to react to every key. We will ignore some and we will only respond to specific controls defined here. We will also make sure each key can be added to this.keys array only once, so when the user holds down a specific key, it will not be added 20 times, it will just be added once. Let me show you. I say if e.key, meaning the key that was just pressed, has key value of arrow down, and at the same time, this key that was pressed is not yet included in this.keys array, so this.keys index of e.key is equal to -1. You can also say is more than -1. In JavaScript, when element has index -1, it means it's not present in the array. Then I just do this.keys push e.key. So if the key that was pressed is arrow down, and if arrow down is not yet inside this.keys array, push arrow down into this.keys array. I can console log key that was pressed and this.keys array. You can see it will stay empty until I press arrow down. If I press it, it will be added to this.keys array once. I will also create an event listener for key up event. If e.key is arrow down, meaning if the key that was released is arrow down, I will use splice method to remove it from this.keys array. Splice method takes at least 2 arguments, index of the element we want to remove and how many elements to remove at that index. Let's test it. Actually, to test it properly, I want the console log after the if statement. Now, when I press arrow down, it gets added to this.keys array through the code inside keyDown event. When I release it, key up event removes it from the array. Perfect. I also want to listen for arrow up key, so I use OR operator. Be careful about brackets here. I have to wrap this block in brackets like this. If key that was pressed is arrow down or arrow up in brackets, and at the same time the key is not yet present in this.keys array, only then push it inside. I also need to make sure I remove that arrow up key on key up event. Again, pay attention to how I use brackets here. It's easy to make a mistake here and break your code. We will also listen for arrow left, so OR operator e.key is arrow left, and another OR operator and I check for arrow right. I will check for one more key for now. I will use it for a special move and attack. And you can use Alt, Control, but be careful. Mac and Windows call Alt and Control keys differently. They might have a different value. Console log E.key and press them on your machine to check for that value. In this case, I will use Enter key, which should be more universal and compatible with both Mac and Windows systems. Let's add all these keys to key up event as well. And I have to make sure my syntax is correct. Now it should work. I click my canvas to select it, and when I start pressing arrows and enter, I can see they are correctly being added and removed from the array. You can see we are also keeping track of multiple key presses at the same time. Great. So now, this.keys property on input handler class always contains all currently active keys. I have an instance of that class here, saved as this.input. For every animation frame, I want to pass the current list of active inputs to player update method as an argument so that it can react to it. I will pass it this.input.keys. Inside player.js, I make sure the player expects that input value. I will call it, for example, input. It still refers to this.keys array we have on our input handler class. Inside update method on player class, I want to check if it includes specific values. I use built-in array_includes method. I could also use index_of method here, it would work the same. If input includes arrow right, increase horizontal x coordinate of the player by 1. Else, if it includes arrow left, decrease x by 1, making the player move left on the negative direction on horizontal x-axis. I actually need to say this.x to correctly refer to the property from line 6. The error I'm getting now is because I didn't save my changes to input.js or main.js files. With file structure like this, when we're using modules, we always have to make sure we save every file whenever we make any changes to it. Now when I press right arrow, player moves right. When I press the left arrow key, the player moves left. Let's refactor this. I give player a speed property and initially I set it to 0. I also give it max speed property, which will be its speed in pixels per frame when it's moving. So this section of code will handle horizontal movement for every frame. I will increase player's horizontal x position by its current speed. So right now the speed is 0, so the player is not moving. Down here I say if input includes arrow right, set this.speed to max speed. If it's arrow left, set speed to minus max speed. Now I can move left and right again, but I can't really stop. There is no condition when the speed returns back to 0. I can fix it by saying else this.speed is 0. Meaning if input array doesn't include arrow right or arrow left, stop the horizontal movement. I also don't want the player to be able to move outside of the game area, so I need to introduce some boundaries. I say if this.x is less than 0, set this.x to 0. Now I can't move past the left edge. I also say if this.x is more than this.gameWidth minus the width of the player, set x to gameWidth minus player width. Now I can't move past the right edge of game area as well. Perfect. It's time to handle vertical movement, which will include jumping and also a special dive move where we crush enemies from above. I create a new class property called this.vy, velocity y, basically a vertical speed. Initially I set it to 0. For every animation frame, we will add the current vertical velocity, Vy, to player's vertical y position. Currently, Vy is set to 0, so there will be no vertical movement at first. I will have to check in multiple places in my code whether the player is standing on solid ground or if it's currently in the air. To make our code more readable and to avoid code repetition, I will put that check into a small utility method. I will call it, for example, onGround, and I just want it to return true if the player is on ground or false if the player is in the air. I do that simply by saying return this.y is more or equal to height of the game minus the height of the player. Let's start by saying if input includes arrow up, set this.velocity y from line 8 to minus 20. I press up arrow key and the player just flies up off screen. Okay, that worked. I only want the player to be able to jump while it's standing on ground. I don't want it to jump higher and higher in the air when we are pressing up arrow repeatedly. I add one more check here to see if on ground from line 28 is true. I set velocity y to minus 2. Nice. If you want a nice jumping curve in a 2D game, we usually do it by making the power of the jump, in our case Vy property, work against the gravity or weight of the object. and while that object is in the air, we keep increasing its weight until it eventually is higher than its jump power, and it will make it slow down and start falling down. Let me show you exactly what I mean. This used to be a bit confusing for me, but it becomes easy when you use it a few times. I create a new property called this.weight, for example, and I set it to 1. So we have velocity y property on line 8, and when we press up arrow key, we set it to -10. This will be the power pulling the player upwards. At the same time, I want the weight of the player from line 9 to be pulling it down, and I want that pull to be stronger the longer the player is in the air, to get that smooth curve when we jump. I do that by saying whenever this.onGround is false, whenever the player is not standing on the ground, increase its velocity y by this.weight. Nice, we kinda jumped. I also need to make sure that when the player lands back on the ground, velocity y is reset back to 0 to stop all vertical movement. I say else this.velocity y is 0. For this to actually work as intended, I need to first run this line of code and then this one. And we are jumping. Velocity y is constantly being added to player's vertical y position. At first it's 0, so nothing is happening. When I press up arrow key, I give it a push in the negative direction on the vertical y axis, so upwards. At that point, the player is currently not on the ground, so this line of code will start running, and velocity y, which is currently set to -20, and which is moving the player 20 pixels up per animation frame, will start decreasing by this.weight from line 9, so -20 plus 1 is -19, -18, -17, all the way to 0. When we reach velocity y of 0, player is at the peak of its jump, but it's still not on the ground, so this line is still adding weight to velocity y, making the player fall down faster and faster. When the player hits the ground, this else statement will set velocity y back to 0 and the jump is finished. The ratio between weight and this minus value will determine the curve, height and speed of the jump. I will keep weight at 1 and I will adjust velocity y to make the player jump all the way to the top of the game area. We have running and jumping. I would like to add more player states and properly animate them. We need a fireball attack, and when the player sits down, I want the game to stop scrolling. How do we organize and manage this functionality? By structuring our JavaScript code in so-called state design pattern. I will show you exactly how to do that in the next part. There is also a special standalone episode with a separate small project where I explain state design pattern and I follow the logic in a more beginner-friendly way to help you understand. Congratulations on completing today's class. We covered a lot today. See you in the next one.